My name is Sylvestre Maurice. I'm a scientist from France in Toulouse. And I'm here in Los Angeles, and especially at JPL in Pasadena, to assist the landing of a rover on Mars. MSL, Mars Science Laboratory, is a project we started with NASA about 10 years ago. The plan was, and is still, to land a big rover on Mars that carries about 80 kilos of scientific instrument. It's happening in a few hours now. We are less than 70,000 kilometers now away from Mars. That is, we've already driven 560 million kilometers. It was far away. The spacecraft was launched in November 26. So we're about to arrive, and it's a difficult part. It's a time where you have to slow down as much as you can. We gave a lot of speed to the spacecraft to exit the Earth. But now we need to slow down. We're going to enter the atmosphere. We're going to slow on the atmosphere using a shield, heat shield. We're going to open a parachute. We're going to open some rockets to slow down and deploy the spacecraft at the surface in a few hours. So it's extremely difficult, it's extremely challenging. NASA is telling us it's the hardest, the most difficult project they ever done since arrival of the man on Moon. So they're expecting something like 11,000 invited this evening. And so the press is here, a lot of VIPs, but a few scientists, and we are these few scientists who have been working on the project, have been building the instrument, science instrument, to do the measurements on the surface. It's a lot of 350 scientists all together to work on MSL. So having been working on this project for 12 years, I can tell you that I'm extremely anxious. But it's going to work. It's going to work because we know we've done everything we could. We know that we're working with the best possible people. I'm not sure you're aware, but people at JPL are the best ever people who can really land and drive a rover on another planet. So if we had to fail, I can tell you we try hard, and if it was not hard, we wouldn't do it. Easy stuff, it's not fun. So it's time to land. And after we land, we're going to start the operation of the rover, which means that right away, we're going to send a series of sequences to turn on the instruments, one after the other, just to tell, hello, are you okay? And the instruments should say yes. And if they all say yes, the 10 different instruments will be really happy. But it's only the start of a story. The story is going to last for 2 years. Why is that 2 years? Because 2 Earth years is equivalent to 1 Mars year. So we're going to stay 1 Mars year, winter, summer, fall, spring, all together, night, days. It's going to be a long story, a long journey in the Gale crater. The place where we land is called Gale. It's a big crater that was created billions of years ago by the impact of an extraterrestrial object. It created a crater of about 150 kilometer diameter. On that crater, at the center of the crater, is a mound. It's a small mountain. And this mountain has recorded the history of Gale crater on Mars. We have already detected a lot of sediments from orbit with our different orbiters. The one from ESA, Mars Express, or 2 from NASA, Mars Odyssey and MRO. These 3 spacecraft have seen amazing things on this crater. So we've decided to go land inside of the crater. So that's what we're going to do, go inside of the crater and drive for 2 years. And then we're going to operate our 10 different instruments. We're going to dig, we're going to measure, we're going to fire lasers, and do a lot of things just to find out if Mars in the past could have been habitable. It means that we're not going to look for life, we're going to look if the planet could have everything you need, atmosphere, water, carbon, hydrogen, everything you need to develop life. So that's the goal we have on this mission. Well, when NASA decided about in 2004, decided to run this mission, they have asked people, scientists, if they could provide instruments. Many consortia of people have replied to this announcement of opportunity with different concepts of instrument. Well, it happened that in France, especially in Toulouse and in Paris, two different teams have proposed instruments for this mission, and they've been selected. So we're now running on this 10 instrument payload, 2 of them from France. And that's why we are here. One is called ChemCam. It's a chemistry camera. Well, it's a laser on top of the rover mast that is able to shoot at rocks. But 10 meters, well, 10 meters away it could do it, but I'm not sure it's going to work. Suddenly 7 meters, 5 meters, 2 meters away, shoot at rocks and create a plasma. A plasma is a small gas of particle that emits light. When it emits light, it tells us about the composition of the target. It tells us the target contains iron, contains barium, strontium, hydrogen, carbon, oxygen, everything. So this instrument is called ChemCam, and it was developed in France by a lab in Toulouse. It's called IRAP, an Astronomy and Planetology Lab in Toulouse, with a lot of partners in Paris, in Nancy, Grenoble, Lyon, a lot of places in France, and of course with our space agency, the CNES. Well, the other instrument is called SAM. It's a sample analyzer at Mars. Actually, it's a laboratory, it's an analytical lab, which means we're going with a rover, with the arm of the rover, we're going to take samples, dig, grab, carry samples, take them, put them in ovens, and then we're going to warm them up. We're going to degas all the particles inside of this small piece of targets, and we're going to learn what they're made of. Not only the chemicals, but also the isotopes, and also the different molecules. So it's a very interesting lab, and a part of that was built by France, by LIBS, which is a lab in Paris, and Michel Cabane is responsible for that. And we've provided the gas chromatograph from SAM. So France is part of this extraordinary adventure that is run by NASA and the US. It's an extraordinary partnership. It's a fantastic challenge. It's about to happen now.